Hello, I'm Bill and I'm a Field Application Engineer. Welcome to this Omron Tech Talk. During this video we'll see a feature introduced with SYSMAC NJ and NX series controllers version 1.40 to simplify the setup of IO-Link devices with SYSMAC Studio. I have an NX1P controller with an NX-ILM 400 4-port IO-Link master unit. Connected to the ILM 400 I have a selection of IO-Link sensors. E3Z and E3AS photoelectric sensors, an E2E Next proximity sensor, and an E3S color mark sensor. Just to recap on a couple of IO-Link fundamentals. First, we have process data, the basic I/O data that gets refreshed in a cyclical manner. Here we can see the 2 bytes of process data for the E3Z sensor that are read every 1.1 milliseconds by the IO-Link master, such as the control output, signal stability, warning and error flags. Second, we have service data, which is read/written as required by the controller. In this example from the E3Z datasheet, we can see that we can read and or write the switch point logic for the E3Z via index 61 subindex 1. With SYSMAC controllers, we use the IOL read object and IOL write object instructions to access the service data objects. All IO-Link sensors follow the same basic principle regardless of manufacturer. And different sensors will use different amounts of process data. So the E3Z uses 2 bytes, the E3S 4 bytes, the E2E Next 2 bytes, and the E3S color mark sensor 8 bytes of data. Switching to SYSMAC Studio, I have a blank project for my NX1P2. I can go online with the controller, go to the CPU rack, and I will do a compare and merge with the actual configuration of my CPU. And I can see my IO-Link master here. Coming offline, to manually configure the PDO assignments, there are 2 key steps. First, click on Edit Unit Operation Settings. And for the purpose of this video, I will ignore device verification and backup and restore settings. But notice that the process data in length defaults to 2 bytes. That's port 1, port 2, port 3, and the same for port 4. Remembering that our E3AS sensor on port 2 requires 4 bytes, I need to change that to 4. And close the dialog. What I need to edit next is the Io Allocation Settings. So notice for port 2, this defaults to 2 bytes of data. Same with port 3, port 4, and it'll be the same for port 1. So on port 2, I need to add another 2 bytes. So I add an IO entry, find port 2 data 2, click on OK, so I now have 4 bytes of data. I can now go to my IO map, open up the ILM 400, and we'll see for port 2 I have 4 bytes of data. However, with NJ and NX series controllers version 1.40, we can get SYSMAC Studio to do all this for us, plus more. Closing the IO map and going back online. In the CPU rack, if I right click over the ILM 400, we have this option here, IO-Link Master Simple Settings. I select that, and firstly note in the toolbar it shows the IODD files for the sensors. Right clicking in the IO-Link Master pane here, I can install IODD files from third-party manufacturers. Clicking on Compare and Get Actual IO-Link Device Information, the IO-Link Master has looked at all the IO-Link sensors I have connected, so I can pull this information across. And notice for each of the sensors, it now identifies how much process data for each sensor. So 16 bits or 2 bytes for the E3Z, 32 bits or 4 bytes for the E3AS. And also notice that the first 2 bytes for the E3AS are the detection level, the next byte is the incident light level, and the last byte it shows you the bit offsets for the various flags. Also note this radio button, which is selected by default. When I click on OK, the ILM 400 unit operation settings and the Io allocation settings will be updated automatically. Also notice this message here, that when I transfer this configuration to the controller, make sure I deselect this option. We'll see that in a moment. So if I come offline and have a look at the unit operation settings, we can see that the device vendor and device type and the process data length has been automatically updated. 2 bytes for the E3Z, 4 bytes for the E3AS, 2 bytes for the E2E Next, and 8 bytes for the E3S. Also, in Io allocation settings, the number of data bytes has also been automatically adjusted. I can go online with the controller and transfer the configuration down, remembering to deselect this option. The configuration has been downloaded and we're back in run mode. If I open the IO map now, and if we look at port 1 for the ILM 400, we can see that not only have the correct number of processed data bytes for the E3Z sensor been allocated, the 2 bytes are named along with names for the individual bit assignments for the control outputs, signal stability, etc. Similarly for port 4, we can see the processed data bytes and bits named. So if I pass a red object under the sensor, we'll see the amount of red incident light change. I hope you found that useful. Thank you for watching.